Good morning, guys. I got some video pointers for this summative review lab that you have from me, or you can get from the calendar on Canvas. I know that there's some questions about, can I raise my grade with just formative grades? What if I want to raise my grade, but the summative category what's bringing me down, or the interim category? I'm actually hoping by the time you're watching this video, I have some more answers for you on that question, but I will keep you in the loop as I hear from the district if we are allowed to give you guys summatives or interims. Obviously, if you're looking to improve your grade, I'm down, so we might have to be a little creative in how we figure that out, but let's just try to get through this week here first. So can we have a summative? If the answer is yes, if the district says yes, actually you can do interim and summatives, this is what you can be prepared for. On Monday, you will take an individual summative test on Canvas. We haven't really done Canvas tests before, but for the most part, it's going to be the same as if we took it in class. We'll talk about what you can use, but you'll actually write out your answers and then upload pictures of them so I can see your BCA tables and all your work and stuff like that. And then on Tuesday, you will do a typed or handwritten with picture uploaded individual lab report, very, very similar to what we're going to do today. So today is a practice for this individual lab summative. I will give you a video like I'm going to do today with the lab techniques and give you the numbers that I measure. So the data will be essentially provided for you, but you'll have to know how to use it and how to use it in your calculations. If the district says we're still not allowed to do summatives, I think this review is still valuable because you're seeing how a stoichiometry lab works, even if you're not going to do your own. And so if we're not going to do any of the summatives for stoichiometry, then we will start gas laws unit 11 next week. So what are you allowed to use on the summative? You can use your periodic table, and remember on the back, this whole section is all for stoichiometry. So you can put some things in here for stoichiometry, maybe some BCA table examples, right? B plus C equals A, maybe some info on how to find X, maybe some stuff on the empirical formula, and molecular formula, right? We are also going to learn how to write a CER paragraph for stoichiometry labs. So some of that information might be helpful. Really anything that you think would be helpful in terms of the BCA tables and doing stoichiometry to empirical molecular formula, and then anything lab-based we talked about. Maybe that formula for percent yield. Again, I'm sure you have other ideas, but look back through the stoichiometry unit and all of that will be helpful for you in what you want to put on your periodic table. You will also be allowed to use your mole island because we know stoichiometry, after you balance the equation, the next step is to convert to moles if it's not already in moles, and then obviously a calculator as well. So you should see this summative review lab direction page either on Canvas or in your packet that you got before spring break. And so here's kind of the overall information page about the review lab. You are not actually going to do the lab. You're going to watch me do the lab and we'll get some data together today. But here's the purpose of the lab. We want to use a double replacement reaction of aqueous solutions of sodium carbonate and calcium chloride to find the percent yield of sodium chloride. So figure out the percent yield of one of the products. Here's the procedure that I'm going to walk through. So this is the lab procedure. Part of your report is to summarize this procedure in your own words. So you'll still have step 1, step 2, step 3, but you're basically putting it in your own words. Then there's, as you can see, a whole section of questions and calculations, but those will be done on the lab report sheet. So those questions are written out for you on the lab report sheet, but this sometimes gives you a little extra information or just puts it all in one place if you want to see the questions ahead of time. So this is your lab report sheet. This is a template, and everything on here is going to look exactly the same as the summative lab, except I'm not going to give you little directions like this. So the review is meant to give you a little extra information so you know what I'm looking for. So again, it'll still be the bolded words, the outline for you, but it's not going to say in the data table to include units. I'm going to expect you to remember that. So you'll have the title of the lab. You can make it a creative title or you can just call it Stoichiometry Summative Review. The purpose you can copy from the lab sheet. diagram is a drawing pictures of everything we used. So any lab equipment that you see me use, you need to draw a sketch of it. So if you see me use a 250 milliliter beaker, I expect to see a little sketch. And then for materials, it says label the diagram above. So I'll say 250 milliliter beaker. So basically anything you see me use, we're gonna draw in our diagram. Procedure is a step-by-step procedure summarizing the steps in your own words. So if we look back at that sheet, it has the procedure. You are using that as your guide, but you're putting it in your own words. And then data. Notice there's numbers filled in already for you. We are actually going to fill in our own numbers today because I'm going to do the lab for you in my kitchen. So you can ignore those given numbers for this summative review lab. So there's calculations, and it says show all work with units. So you will have a balanced reaction. You need to find the mass of sodium chloride produced from the limiting, which is your theoretical yield. So this is going to be our BCA table. We need our actual yield. So this is going to come from lab data. How much did we actually collect? And then our percent yield. Here's the equation. Do you think that will be on your summative? Absolutely not. So that would be a good equation to put on the back of your periodic table. Okay, and then conclusion. We will, in a second video, work on claim, evidence, and reasoning with all these specifics. But again, those underlined sections in red will not be on your summative lab. You'll have to remember that info yourself. All right, guys, welcome to my kitchen. I may or may not have stolen some lab equipment from Legend High School. Don't worry, I'll return it, I swear. Don't really want this in my house for the rest of the year. But anyways, so here's the directions, and I just copied and pasted it from the procedure. So number 1 says pre-weigh and record the mass of an empty 250 ml beaker and label it beaker A. So this is a 250 ml beaker, so I'm going to zero out my balance. $111.85. So notice when I did this a different year, we had a different mass. Not all beakers are exactly the same. So we're going to actually use this mass today, 111.85. Okay, now it says obtain a 150 milliliter beaker and label it beaker B. And obtain, mass 0.75 grams of calcium chloride directly in the beaker and record the exact mass obtained. So I am going to put a weigh boat on here so I don't get my balance dirty. Zero this guy. Calcium chloride. Oh, and it says put it right in the beaker, so we'll actually do that. So I zero it out, because it doesn't say I need the mass of that guy, and I need 0.75 grams of calcium chloride. So I'm going to use my scoop. I'm using a scoopula. There we go, scoopula. Scoop out this guy. I need 0.75 grams. Whoops. Way too much. Try that again. I don't need that one on there. Getting a little closer. We'll take that, maybe one little sprinkle. That, oh yeah, almost perfect. We'll take that. So we're going to record the exact mass. So that's mass of CaCl2. So that's 0.77 grams. And that's actually the number we're going to use in my BCA table. Not 0.75 because I'm actually going to be mixing 0.77 grams. Now it says use a mortar and pestle to crush the calcium chloride. So I'm going to actually transfer this into a mortar and pestle, because if you look, the calcium chloride's kind of like almost like Dippin' Dots. So we want to actually grind this up a bit. So I'm going to grind this guy up so that it's smaller pieces. And transfer it back into this beaker. Now it's more of like a powder. Add about 20 milliliters of deionized water to the beaker and dissolve the calcium chloride with a glass stir rod. So, let's cap my chemical. And we are going to add about 20 mils of DI water. So I have a graduated cylinder. And I'm going to measure about 20 mils of DI water. It's pretty good. And I'm going to put it in, mix my calcium chloride, and stir. Here's my glass stir rod. And once it's all dissolved, my compound will be aqueous. All right, guys, step 3 says to measure out 0.4 grams of Na2CO3 directly into a different beaker. Na2CO3 is called sodium carbonate, and label that beaker C. So I zeroed out my balance, got my scopula and my chemical, and I need 0.4 grams. I'm going to try to do this a little more controlled than the last one, so I'm not throwing away unused chemicals. Whew. 0.33, we're very close. Just a tiny, tiny bit more. That'll work. 0.42 grams, and add about 15 mils of deionized water. That over here. I measured out about 15 mils before making this video, and we want it to mix and dissolve. So I will stir this reactant as well, so that way I have 2 aqueous. Oops, hold on, let me record. We said 0.42 grams of that other reactant. So when I do my BCA table to find my theoretical yield, right, that's the nerdy one, I'm going to use 0.77 and 0.42 grams for my BCA table. Step 4 says slowly add the sodium carbonate solution to the calcium chloride solution in B, stirring gently. So I'm going to slowly pour. This is my reaction happening. Look at that. That is thick. We made a precipitate. That's a sign that a chemical change happened. Interesting. All right, this step says set up a funnel with pre-weighed filter paper. I'll talk about that in a sec because I actually didn't weigh mine. So this is filter paper. What I did is I fold it so it looks like a funnel, and then I actually put it in the funnel. So that way no solids can get through, but water can drip through. And then I have a clay triangle. That's this guy holding the filter. That's honestly just because it holds our funnels real nice. So we have filter paper, a funnel, clay triangle. This thing holding it is called the ring. And then we have a clamp and the tall ring stand. So we set it up, and I put beaker A, the one that we weighed ahead of time, underneath to catch what's dripping. Okay, while stirring the reaction mixture, let me try to get this. Okay, I'm gonna pour it into that funnel. So again, I'm sorry if this is hard to see, but I'm going to pour, maybe I'll stop the stirring so you can see. Pour this guy, and here's what's gonna happen. Those white thick particles, and I'm gonna pour all of this in there. Those white thick particles are gonna get stuck in the filter paper, and we should have then clear, aqueous dripping down, okay? The reason I did not pre-weigh the filter paper is step 7 says throw away the solid on the filter paper. That's calcium carbonate. So I don't actually care about the product that's sticking to the filter paper. I don't care about those white solids because the problem we're trying to solve is the percent sodium chloride, the percent yield sodium chloride, not calcium carbonate. But if I did care about calcium carbonate, could I save that paper? Absolutely, and that is a time we would want to weigh the filter paper ahead of time. In this case, I care about what's dripping below, and remember, we weighed that beaker A ahead of time. All right, so here's what you missed out on. We mixed calcium chloride, well, you were here for this, but we mixed calcium chloride aqueous, because we dissolved it in water, 0.77 grams of it, with sodium carbonate, 0.42 grams aqueous, because we dissolved it in water. And I just was able to watch 30 minutes of television. This is us, in case you were wondering, trying to catch up, while this guy filtered. So I even rinsed this beaker out a few times with the deionized water bottle, made sure I got out all the solid particles, and I let it drip, drip, drip for 30 minutes. In here, you can see that there's that white powder. That is our calcium carbonate product. We don't care about that for this particular lab because the problem didn't ask about it. So down below must be what we care about. We made NaCl. If you know anything, NaCl is salt. Does this look like normal salt to you? No. It looks like salt water to me, right? Because we dissolved it all in water. So that's on to our next section. We have to get the water away. And so I'm going to put this guy on a hot plate that's been heating up, and I'll check back in when it looks close to done boiling. All right, been here for a while, 30 plus minutes again. Aren't you glad I'm doing this and not you? And we're getting close, like the water level is going down. I don't know if you can see the steam. But I will notice that I had to turn the temperature down because some of the water was splattering out a little, like it was boiling too aggressively. So I did turn my temperature down just a little so it wouldn't, hopefully I could get boiling still, but not any splattering to happen. So we'll check back in a couple minutes. All right, we are getting close. Whoa, that's a good sign. Turn it down. Okay, so we don't want to burn the salt because burning is a chemical change. So we got a little bit of water, but it's still hot enough. It's kind of boiling off. Okay, so I'm going to put this down to cool because I don't want, if it's hot, it won't get the proper balance reading. But here, let me grab them. I'm trying to not burn myself. You can see the salt is kind of caked on to this beaker. So I'm going to let it cool, and I will get the mass. I'll zero this guy out. Once it's room temperature, I'm going to put it on the balance and fill out the mass, my data table where it says mass of 250 ml beaker and NaCl, right? Because they're caked on together. All right, let's see if that works. So I zeroed out the balance, and this is my room temperature beaker with the salt in it. I put it on the balance. And it says 112.79 grams. That is my mass of 250 ml beaker and NaCl, 112.79. So we'll take my little pen, 112.79 grams. Okay, so that is the lab portion. I do have a second video to help you with the CER portion, but here's what I would like you to do. When this video is over, I want you to do lab title, purpose, diagram based off what you saw. Same with labeling the materials. Rewrite the procedure in your own words. We now have this new data table, so that's taken care of. I've written the equation, and again, it says balanced reaction. I got this from that direction page. Remember, there was that one sheet, almost like a one-pager with the procedure and what calculations and things you would do. So I got that from here. I would like you to balance it, though. It is not balanced. And then you're going to do your BCA table. So you'll use your starting grams of this guy and your starting grams of this guy from the data table. And we want to find the theoretical yield of NaCl. So your question mark is how much NaCl will be thereafter. The actual super simple calculation you should be able to do, I want to know how much did I actually make in the lab. We didn't directly measure it, but there is a way that you can figure it out using the numbers in your data table. And then I want you to find the percent yield. Okay, so do all of those things, and then you're going to come back and watch the shorter second video about CERs.